Environmental economics.
Not necessarily. So
Not much going on out there besides a bunch of rain. So where I want to start is just with an open-ended discussion. So far in this class, we've thought a lot about how to regulate emissions of goods and externalities. So one particular externality that's very important in the world is carbon dioxide emissions. And I just want to think big picture, not in terms of what policies you would pursue, but what technologies you would use. If you were in charge of reducing carbon emissions, what would be your target? What would you ask people to do? Like no more air travel, switch light bulbs, curb deforestation, these kind of things. What are your ideas for what different processes or technologies would be most effective for reducing carbon emissions? Yes.
I think if it's like focused on like consumers,
Yeah.
then I would take an approach of instead of shifting their behavior, I would alter what they're doing. For example, out in California, we have catalytic converters. I would maybe make that nationwide or like all over the world.
Okay.
And so that way, you're not necessarily messing with consumers' behaviors of wanting to drive, but instead reducing their emissions outside.
Great. I'm not going to impose any commentary on the answers. Just want us to put a lot out there. Yeah.
I think, for me personally, putting it on the consumer is the incorrect thing to do because I think the producers are like 99% of all global emissions at this point. And so I feel like for me, I would probably put something on the producers, whether it's like a requirement or standard for using, a specific type of energy or air, or like, enforcing like, okay, by this year, like you have to use solar power or something like that, because I feel like putting it on the consumers what we're trying to do, and at this point it's obviously not working, and the producers are also like I think there was this statistic I saw the other day that was like a single like OpenAI like power like grid uses as much energy in a day as both San Diego and New York City combined. That's not our fault as consumers. That's something that we have to enforce on producers, or we're not going to get anywhere.
Okay. Great. More thoughts? What technologies would you advance to reduce carbon emissions? We're about to look at a lot, but I'm curious. Okay. So I'm going to show you a chart. Okay. So as we can see from our answers so far, we have a lot of different options. We could require a firm to change their energy input sources or their use of energy in some way in their process. We can tell consumers to use less power at home. We have a set of options. And in the case of carbon emissions, some folks went through all of these different technological options and they ranked them. So I'd like you now to study this chart on the slide for a minute and understand what it's saying. So the next question I'm going to ask you is what this chart is showing us. How do we interpret this? Yeah.
I think it's similar to what you were saying earlier about how, policies that involve going back to the producer are more effective than the ones that are like brought to the consumer.
Let's just stick with before we assess how we should take away, what is it showing us? If you had to describe it to someone who didn't see it in front of themselves, how would you articulate what it's showing? number of options to reduce carbon emissions technologically. We could encourage, for example, or envision a world where we've done a lot of switching to hybrid or electric vehicles, perhaps in combination with cleaning up the grid. We can envision a world where we don't bother doing any of that, and instead we just get some magical technology that's gonna suck all of the carbon out of the atmosphere. So which one of those options is going to be the better one to pursue first? And by better one to pursue first, we can have a number of criteria. But a key one here is how costly they are per unit of carbon reduced. So I think it was hopefully intuitive to most people that it's pretty low cost per unit of carbon saved to switch to a hybrid or electric vehicle. And it's very high cost to do all of the technological development and then to actually pay the energy costs to do something really fancy like geoengineering or sucking carbon out of the atmosphere. So if we're gonna do one first, the one that seems the most cost effective at first is to switch the cars before we bother with the fancier things. So we'll switch cars, we'll see where our carbon's at, and then we'll consider if we need to take the next step as a society and pay for that higher cost abatement. So with that logic in mind, what is this chart telling us are the most per unit of carbon saved, the most efficient technologies? What technologies give us the most bang for our buck at reducing carbon? Yeah, in the back.
Switching incandescent to LED in residential homes.
Yeah, it's really dramatic. Can you add anything to that interpretation?
It's super cheap. It's like a low hanging fruit.
It's so cheap it actually pays for itself. It's negative.
Yeah.
So you save more from having switched to incandescent than it costs you to switch to incandescent and paying less for electricity, according to this estimate. So everything in the negative area is a pay-for-itself technology. And then everything in the positive area is a costly to society investment, with increasing carbon capture sequestration being the most costly way to reduce carbon emissions. What does the width of the blocks in the chart tell us? It's kind of like when we think about the interval. But don't let that mislead you. Yeah, keep guiding us.
The volume of emission reductions, like the amount that technology can reduce per year.
Yeah, so let's imagine the light bulb situation. If everybody, we switch to literally every single light bulb, we only get to overall meet less than 1 gigaton of carbon emissions per year. That's the best that can do for us in the world. Unfortunately, we won't save ourselves just by switching light bulbs. We need to do another thing. The next thing's gonna be a little more costly. So we have all these options, we arranged them in terms of how costly they are, and then the width tells us how much carbon can be saved. Okay, so how does this relate to the cost? So far, when we've thought about something with an externality, we've thought that the only way to reduce the externality would be to reduce the quantity of the good produced. So we thought about steel, it has an externality, but the only way to reduce the damages from the externality was to produce less steel. Is that a fair interpretation of our model so far? Similar with Coase bargaining, somebody was damaged by someone else's activity. The only way to change it up was to reduce the activity. It's been a convenient premise for us so far. It's kept the model nice and simple. But in real life, it's a little bit more nuanced because I could produce the same amount of steel with less carbon emissions if I simply switched to perhaps like a different source of energy. Maybe I go with solar power instead of coal-fired power in my production of steel. And then I have less externality, but I haven't changed the quantity of steel. You with me on the logic? So that's the idea now. We're gonna switch to focusing on modeling the units of the pollution or the bad thing or the environmental damage entirely from the production of the good that it's associated with. So we'll start it setting up and then we'll revisit here. Okay. So switching to notes mode, which is going to take just a moment with the technology. For helping. Oh, good. Okay. You just had to touch the device. All right. Okay. So today our theme is market for abatement. So we'll do this sort of basic model to introduce the concepts, and then we'll have multiple plants moving. So just want to articulate what we've said, a little more formal in the notes. What do I mean by abatement? I mean reduced pollution. So we were just looking at this for carbon, but we can have a marginal cost for any arbitrary pollutant. We might also call this the marginal abatement cost curve. So all the way on the left is no abatement. What do I mean? Full pollution. And then we can imagine a world with lots of pollution reduction. Okay, so recap, before we thought about the world with good. It's still a good, but now the good is the foregone pollution. So same model, but now we're just going to use the word abatement. Abatement is our special good, and it means lessened pollution from the status quo. And we've described that there can be different options for achieving reduced pollution, such as carbon. Some things are relatively easy. We're going to say like changing light bulbs. And some things are super expensive, like new technology. Carbon capture, sequestration. We can rank those in terms of their per unit of pollution avoided cost. If we do that, we get the marginal cost of abatement curve. marginal cost of abatement is like the supply of pollution reduction. Each additional cost to society for an X unit of abatement is this curve plots the additional cost to society for the X unit of abatement. Abatement means pollution reduction. So just focusing on that X-axis, if abatement, which I'm gonna label with X, introducing some notation. If abatement, also X, is 0, that means pollution is at its highest possible. I'm gonna call that Q bar. So business as usual pollution. So far so good? Question? So in the same way that we can have supply and demand for a good, we'll have supply and demand for pollution reduction. So our equivalent of demand, we're gonna call the marginal benefit of abatement. Our x-axis is now going to be abatement. Has valuations. There's a marginal abatement cost. And a marginal abatement benefit. And then this is going to be equivalent to our social marginal costs and our social marginal benefits of abatement. So typically our x-axis is some good, cigarettes, wine. Here it's foregone pollution, we're calling that abatement. We're giving it a special variable because we're gonna talk so much about it, x. We'll notice that when abatement has been completely done, there is no longer any pollution left in society. Pollution, Q, is equal to 0. And abatement is equal to Q bar. Let me give you a little more space in between those two. When we have reduced all of the pollution there possibly is, we've introduced the variable for that, Q bar, business as usual pollution. Then pollution level, Q, is 0. And abatement is at the maximum Q bar. So that's our maximum here. When we've done no abatement, abatement x equals 0, we'll notice that pollution, Q, is at its max possible. So we just have two mirroring versions of the x-axis with abatement and pollution. sides of the same coin. Abatement goes up, pollution goes down, abatement goes up, one for one. Question? We'll also note, what do you think this is? The benefits to society of reducing pollution? And this is a philosophical question. Can we actually get a slope for that? We talked a bit about it at the first class. Yeah. Do you think we could actually have a curve that's the benefits to society of reducing pollution? That's what this is telling us. The first unit of pollution reduced is worth $1 billion. And the next $900 million. That's the idea. I admit, it's a bit lofty, that's why I'm pointing it out. There's a lot of people, myself included, whose career is about inputting an empirical basis on the slope of this curve for various pollutants like clean air or clean water or carbon. I'm sure you've heard of a concept before called the social cost of carbon. That's the idea here. And that's usually thought of as like, just because it's difficult to model, a flat line. Like, here's the social cost of carbon, $29 million, or actually it's 42, I think, per ton carbon, am I right? I think it's roughly $42 per ton carbon. So that's just a flat line, the benefit to society per unit of carbon is 42. So if we knew that, let's pretend we liked that number. There's a lot that goes into it. We'll try to have some time later in the quarter to think about what goes into those kind of numbers. And then the idea in environmental economics is if we know that number, we can come up with this magical amount, X star, this socially optimal abatement. And we'll note then that there is also a corresponding Q star. Excuse me. That's whatever pollution there had been, minus X star, the optimal abatement, and that's our socially optimal pollution. In general, pollution, Q is going to be whatever the status quo minus abatement. Pollution, status quo. Sometimes I say business as usual, minus abatement, just to keep your brain helped there. Thoughts, questions? Yes.
There's a difference between the second and the third line that like says energy socially optimal, and the last one just like if you wanted to see at a certain point.
Yeah. For any level of abatement X, you can say what the pollution Q is, just helping you translate between those two variables. Okay, pray for me with device switching. Oh wait, I didn't need to do that. Okay, great. So I'm right about $42. So now we can visualize $42 coming across our social marginal costs, our marginal abatement cost of carbon curve. Ooh, did I say a lot of words? This is our marginal abatement cost for carbon dioxide. And I told you that many people think, so roughly here is our social marginal cost. Our marginal abatement cost for carbon, and right over here is what I'm telling you is the marginal benefit of CO2. So this tells us that somewhere around here is what we need to abate in carbon, in theory. And that means we need to be doing things that pursue basically everything except for carbon capture sequestration. And even these numbers are at least 5 years old. And there's been yet less keeping up with, I'm sure, some projections in here. So that's the idea, that we could do this for any pollutant in theory, and we can see how various policies are gonna get us to the socially optimal level and at what cost. That's our goal for the next several classes. Yeah.
I don't understand, what are you showing here?
We'll try that one here. So it got a little messy. It always does. Right. So what we described so far is there's a curve for the marginal cost of abatement. And this is an empirical example that's very similar to what we just saw that looks more simplified. So our more simplified version, let's put it down here. Our simplified version we just saw in the slide in the notes was there was a marginal cost of abatement, X abatement, dollars. It looked like this. This is an empirical example in the case of carbon emissions. That's that line. I'm trying to trace out our blue. So somewhere like here. That's our marginal abatement cost curve for CO2. Then I explained that what we're going to focus now on in theory is that there's also, let's try a new color, social benefits to abatement. So we have some marginal abatement benefit. It might be flat, it might be sloped, and then we can determine a socially optimal level of abatement. In the case of carbon, my memory serves correct. The best we can get out of a lot of people studying this question is one flat number for carbon. We know that's not true. We know that there's certain emission of carbon that's going to get us to a tipping point, and then the damages to society are actually much worse. We'll come around there. But let's pretend carbon had a flat benefits of abatement, and it's about $42 marginal abatement benefit. This tells us that our socially optimal quantity of carbon abatement is somewhere over here. So now we want to think about how we can get society to the socially optimal quantity of abatement. That's our goal for the next several classes. We can introduce taxes, we can introduce mandates, we can introduce cap and trade policy, we can come up with yet more policy options. We want to compare and contrast them in terms of how effective they are, how costly they are, and then who wins, who loses, our standard ways of evaluating the characterizing and evaluating a market. So let's picture here now there's two firms. So we're switching into part 2 of our lecture. We're going to call this our 2 firms. Okay, so what have we done? We've done one basic model. So now we're going to talk about having 2 firms that both can provide abatement. 2 steel plants. So here's our new situation. We're gonna have two firms that can provide pollution reduction, and they have different abatement costs. So in the same way as they're supplying a good, now they're supplying pollution reduction. Firm one can provide X1 units of pollution reduction, e.g. abatement for 24X1. Firm two can provide pollution reduction at cost 8X2. And in the status quo world, let's pretend they both emit 20 units of pollution. That's our business as usual. Yeah,
What does the BAU stand for?
business as usual, or status quo. And we'll switch to iClicker here. And the question I want you to think about is if one firm has to reduce, say we wanted 5 units of reduced pollution, 5 units of abatement, and we have to make one firm do all of it. We can't subdivide. Which firm would be the most efficient? And look at the iClicker. Let's see, 15 more seconds. There's only I think 2 people that haven't replied yet. Okay, great. The majority is right on point here. It's very similar to thinking about the supply of a good. It's our Apple and Samsung from the exam. We needed to have 5 units of abatement supplied. I'm just gonna draw my 5 over here so it's a little closer. If we had firm 1 do all of the abatement, it would need to pay in aggregate this entire red area, cost to firm 1 to reduce by 5 units. And by contrast, if firm 2 did all of the abatement, firm 2 would have to pay in total to achieve 5 units of abatement. The blue triangle, since they overlap each other, we can see clearly that the blue triangle is smaller than the red triangle. So it's better to have firm 2 pursue the abatement. Let me ask you now another question. Instead of one firm having to do all of it, let's pretend we can have them reorganize the abatement amongst themselves. Now, what's the least costly arrangement of abatement between the 2? Sorry, okay, fresh question. we spread out the abatement, should we have it all go to firm one, all go to firm two, split in half, or something else? Okay, I'll take around 10 more seconds. Okay, now we have a little more variation. About half the class thinks we should still have firm two do all of the abating. Some people think we should spread it out evenly, and yet another third of the class think we should do something else. Let's frame how do you imagine that we could answer this. Let's go back to plotting our little 5 units of abatement total. I'm gonna make it too crowded here. So here's our 5 units of abatement. What does the total cost look like if we spread it out evenly? What does the total cost look like if we spread it out evenly? Let's start here. Let's start with firm one doing, firm two doing all 5. So firm two doing all 5. Firm two does all 5. Same triangle is here, right? Let's say firm two did just a little bit less and firm one did just a little bit more. Now what happens to the total cost? What's the first unit of abatement cost firm one? If firm two does just a little bit less and firm one does just a little bit more, how do we picture that? Definitely want someone from the class to articulate it. What's the first unit of abatement to firm one gonna cost? Yeah.
$24.
Yeah, it's gonna be depicted as just a little triangle here. And by contrast, we can see this much bigger area over on firm two side. So if we just take a little bit off of firm two's plate and give it to firm one, we can save some money relative to having firm one do all of the abatement. We can continue to make that argument until their marginal costs of abatement are equal. I'm gonna erase these colors and do it one more way, picturing from the 2.5 status quo, just so it doesn't get too messy. Okay. So let's pretend they're both doing even. So they're both at 2.5. 2.5 and 2.5 add up to 5, so that makes sense. That should get us there. If instead, firm one did a little bit less, so this is why C is wrong. If firm one did a little bit less, we would save this much, and it would cost firm two that much. So we can also see that relative to the even allocation, 2.5, 2.5, we still want to reallocate across the two firms. So that firm two is doing a bit more, because firm two has the lower marginal abatement costs. So our efficient allocation of abatement is where the two firms have the equal marginal costs. just process of elimination ourselves to something else as our correct answer. We'll take a short break here. We'll do this with algebra for the rest of class.
Are you also
Yeah.
Yeah, I mean, I do like environmental resource.
That would know that.
What about you? You like it? It's cool.
Yeah.
I like it, but it's okay. It's cool.
The class.
Just like the major.
Why did I do
Yeah,
way
that's
better
nice.
this one than with my major?
Yeah, that's yeah, I mean, like, some of the classes, like, starting off, they're all right, but like, once it gets like actual, like, in-depth classes, like, it's very cool. So, honestly, I started this business class, I was like, I really just want to learn about numbers and money, so I would rather like learn about like the environment and like energy and stuff like that. So, energy and environment's kind of like where I find, I don't know, I really enjoy work. Because I don't want to like work and just like, like help out the environment or like do like environment. So, yeah. What about you? What did you choose your major? Okay.
Oh, I knew
That's
that it
awesome.
was just because I had the list written down.
That's cool. What did class you take?
Yeah.
Like a wide range of topics.
In fact, I
That's cool though.
because econ is. Oh, a public learner.
That's cool.
I really like it.
That's awesome. This energy econ, and then
They're also very
I don't know what Bush. Yep. I was like right when you like
I think everyone
I said like
one day. I was in from
that's fine. How did you do it today?
Actually, we made a podcast.
That's good. Wait, are you in game one? Game one. Oh no, actually. We're like group 7.
Alright, we'll come back. We'll start off easy. So we're setting up our problem. We have two firms that can provide abatement. Firm 1 has cost 24 x1, where x1 is how much firm 1 abates. Firm 2 has abatement cost 8x2, where x2 is how much firm 2 abates. Before we do any abating, they both pollute 20 units of pollution. Last element to our problem is we're going to say that some fancy academic economists estimated the marginal benefits of abatement. So let's say let the marginal abatement benefit be equal to function of x. And that's going to be equal to 35 minus x, where x, big X, is the sum of how much firm 1 abated and how much firm 2 abated. As we go through this, if it helps, just keep in mind, it's the same thing as supply with multiple producers that we already covered. We just, instead of saying wine, cigarettes, coffee, we're saying reduce pollution. And then we're gonna do all the same things. We're just calling it abatement. So first question, which we just started with, what is the cheapest way to achieve overall reduction in pollution of 5 units? e.g. 5 units abatement. There's an argument. the two firms to provide it, and it needs to add up to 5. Our second condition is we need the marginal cost of firm 1 of its abatement to be equal to the marginal cost of firm 2 of its abatement. Otherwise, we can reallocate a little bit more to one firm, a little bit less to the other firm, and save money. So what we were just looking at in a graph, we've now posed as an algebra question. So we can solve it. We're gonna set 24x1 equal to 8x2. And we'll substitute that x1 is equal to 5 minus x2. Now we'll solve. I think it's gonna work. I have such a fear of making arithmetic mistakes in front of you and confusing you that I don't let myself do arithmetic in front of you. Okay, so we'll substitute this back. We have 3.75 units for firm 1. For firm 2, excuse me, that means what's left for firm 1 is 1.25 units of abatement. So visualizing what we just did, x, here's our 24x1, here's our 8x2. We found where they're equal, and they add up to 5, and that is 1.25 and 3.75. We're gonna call this the efficient allocation. So we found the cheapest way to get 5 units of abatement. Our next challenge is to say what that costs the market to provide 5 units of abatement. So just like when we had 2 suppliers providing an iPhone, we all each has their own individual cost of supplying each unit of phone, and we have the market supply cost of providing phones. So we will add up these 2 individual supply curves to define our market supply of abatement. Okay, little here. So 2. marginal abatement cost for the market X. For the market of X units of abatement. Recall, X is the sum of all of our individual providers of their supply. Meaning we're doing horizontal summation, we're going to aggregate the quantities. So to do that, same steps as before, invert firm level marginal cost. Took our two marginal cost curves and we turned them into functions of the price. So that the outcome variable is now the quantity. Now we can add our quantities. So that one's our X1, this one's our X2. And we're left with P over 6. And then finally, we would like to express the market cost per unit abated rather than the total units abatement per cost. So we're just going to invert once more like we did for plotting the private marginal cost curve when given two firms. So invert again. Let's remember that equal to X. So all I did was just move my 6 from the denominator to the other side of the equation. And now we have values as a function of quantities. So market marginal abatement costs for the total supply, X, that's the sum of firm 1 and firm 2, both firms are incorporated as 6X. Quick, messy visual, in the background with X. Yeah, firm 1, 24X1, yeah, MC2. And so we did a little horizontal aggregation, X1, X2, and then X1 plus X2. That's what we just did. So this was what we just did with algebra, marginal abatement costs, X. Important note. Usually when we think of the supply of a cigarette, we don't think of it as like, we think the market's naturally gonna get us to the most efficient allocation across firms. Pollution, we might do some policies that don't give us the most efficient allocation across firms. So I just want us to note that this is the cost to the market when we have efficiently allocated the pollution among the two firms. So write that out. And think of it also as our social marginal cost at times, is the least cost. So just to note, when we defined marginal abatement cost of X, we thought for X total of 5, that was with the efficient allocation, not something else. For our market marginal abatement cost. What we have left now, we'll do a few more observations. Again, continuing to mirror our private market setup from the very first class. So next we're gonna look for the socially optimal quantity of abatement, and then we're gonna describe what that costs each firm and what that costs society. That's the next couple questions. Okay, so we've just done a marginal abatement cost for a firm market. That was 2, so 3. What's the socially optimal quantity of abatement X star? And I'll flag right after that, we're gonna also ask socially optimal quantity of pollution. Well, to answer this, we have our X, we have our values. We have our market marginal abatement costs. We just solved for that, we're calling that 6X. We had our market marginal abatement benefit, and that was equal to 35 minus X. So to get our socially optimal quantity of abatement, we'll do our favorite thing in economics, we'll find the intersection of the two lines. Condition as before, socially optimal quantity of abatement is for our marginal abatement cost equal marginal abatement benefit. Substitute 6X, 35 minus X. We would like our optimal 6 minus X. So socially optimal quantity of abatement is at 5. What does this mean is the socially optimal pollution? Remember I told you at the beginning that in the baseline or business as usual, our two firms were each polluting, I think I said 20, it's 20. If we have 20 units of pollution per firm, we've abated 5 in total. That means we started with 40 units of pollution, less our 5. We now live in a world where it's optimal to have 35 units of pollution. Pollution. Recall Q bar is 40. That was the initial firm 1 and the initial firm 2. Yeah.
Can you repeat why the Q star is 35 and not 30?
We solved for the optimal abatement. That was the total abatement for both firm 1 and firm 2, big X. We got that because we used the marginal cost curve for both firms put together. So what our thinking is we wanted to find how much abatement overall we'd like to achieve if both firms are supplying abatement. Notice that abatement, it doesn't have, the benefits of abatement are shared, but the supply of abatement is not. Just because firm 1 reduces pollution by 1 unit doesn't mean that firm 2 also reduces pollution by 1 unit. If we want pollution down by 2 units, 2 units need to be supplied. 40 units of pollution in the status quo, we want to abate 5, that would leave us with 35 pollution. Just want to point out, we already found the efficient allocation of abatement for a 5-unit reduction. We just saw for that it was 3.75 and 1.25. So if I set the optimal allocation of abatement between firm 1 and firm 2 at the socially optimal quantity, how much is each producing? You already know that. So x1 equals 3.75, x2 equals 1.25. If instead, yes,
So then optimally when solving for it, we're gonna first solve for optimal and then solve on how we split it between the two? It's like solve for 5, since we kinda knew 5 just as, like, it was a number we were
Yeah.
using.
it
So-
just, yeah, exactly.
Okay.
It depends on where the question wants you to start, if it's an exam or what you want to model. So if instead I said, I might say, first find the efficient allocation of abatement, given these 2 marginal costs. Then you would get your 5. Then you could say what the efficient allocation is across the 2. So do our MC1 equals MC2 at MC x1 plus x2 equals big X. Or we could picture a world where I said, I don't care what the efficient, I don't care what the socially optimal quantity is. I may never know. Let's just pretend I want to get 10 units of abatement somehow. You tell me the efficient allocation. Then all you do is you say, fine, you want 10. I can help you. I'll put 10 here. And I still want their marginal cost to be equal. So I'm just highlighting here, we're not going to do more. This just could be anything and the method's the same. So it just means anything. We could do one there, I think it's a little repetitive, but I'm gonna move on, but we can do another illustration of finding the efficient allocation if we have time later. So I could instead say, if x were equal to 1, what is the efficient allocation x1 star, x2 star? We do the same thing. x1 plus x2 plus 1, x1 plus 1 equals x2, x2. So for any amount of abatement, we can say what the best allocation is across the 2 firms. You can also find the socially optimal quantity of abatement.
Can you scroll down?
Our last big observation today is to say, what does this cost each firm and society? 8x2. And we're at 1.25, 3.75. Cost of firm 1. And 1 needs to pay this area. This height is 24 times 1.25, or 8 times 3.75. Either way, we get to 30. So triangle method, 1/2 of our base, 1.25, and our height, 30. I'm getting 18.75. Method 2. We're looking at the integral from 0 to 1.25 of 24x1 dx1, which is yeah, 12x1 squared, evaluated from 0 to 1.25. 12 times 1.25 squared. 18.75. Same method for firm 2, cost of firm 2. We'll look at firm 2 as red, so firm 2. Here. I'm just gonna do the geometry for firm 2. So 1/2 base, 3.75, and that height of that triangle is 30. So firm 2's total abatement cost comes out to, I'm getting 56.25. If you wish. So we have 2 ways to find the overall cost to society. Is there a question? Yeah.
For the 30, was that just, our socially optimal, like the X star, substituted into the equation on the 30, or was it different?
We are looking at firm 2, just this line, which is 8x2, abating 3.75 units. So the height of the marginal cost of abatement for firm 2 at 3.75 units is 8 times 3.75. And that comes out to 30. So I'm just using the geometry for the 30 to see the height of my triangle. Notice the integral, I didn't need to find the 30. I didn't need to find the 30 there. But I'm somewhat more prone to other algebra errors, personally. Either way, I hope to have the picture to get the formula correct. Okay, cost to society. Option 1. B1. Just add up our 2 firms, this always works. 18.75 plus 56.25. Option 2, notice that if we're at the efficient allocation, which we were, we have that market marginal abatement cost curve, and that was equal to 6x. 124x1 dx2. This market curve is for added up those two quantities, 1.25 and 3.75 to our 5. So we can also just look at this triangle, our market level marginal abatement cost. This only works with the efficient allocation, but that is what we're at. So now we can cut to the chase. We're using the correct market level supply curve. So this is going to be 1/2. I'm looking at my base right here of 5. My height's still 30. Times 5 times 30. And I get $75 both ways. Alternative, switch your calculus if you like. 0 to 5 of 6x. 2x. Alright. Fortunately. Excuse me. We're a class where we're not crazy rushed at the end. What did we learn today? We'll take a minute to synthesize. We have the marginal cost of abatement. So no more do we only have reduction of the quantity of a good. We're targeting exactly the thing we want more or less of in the world, which is pollution. It's PFAS, it's carbon, it's whatever you want to put in it. We're pulling it, and we'd like to reduce it. It has very marginal costs because there's all sorts of technologies out there to achieve it. We can model the reduction of this thing in the same way that we modeled supply and demand for another good. So we mapped our concepts from private supply and demand into the abatement market. That was our goal today. Next time we'll add taxes on top of it. I will flash for your pleasure. The final iClicker assessment, if you'd like to add in anything, taking away from that. Otherwise, we will move into adding taxes, mandates, and cap and trade into this market for our next class.